my name's Willie, and today I want to talk about minutes of angles and mils. Now, I'm not an expert or anything like this, but today I was just in bed and I was thinking about, where did minutes of angles and mils comes from, Even if I kind of knew what target range estimation was and such, things like that I could do with the scope, I didn't really know where mils originated from. So today I found this fantastic document by Robert J. Simon, and it's a guide to understanding what they are and how to derive the range estimation equations. So, on to the topic now with mils and minutes of angles, but this one's just going to be mostly about mils. So, a little brief history about mils is a mil is 1 mil. A mil is a unit of angular measurement. And so basically the military used the mils to help direct artillery fire, and it goes back as far as the late 1800s. Its modern form of use by the military for directing fire was developed in the 1950s. The modern mil is short for milliradians, so a lot of people, when they say mils, it's basically short for milliradians. And it is a trigonomic unit of angular measurement. So we're going to do a little bit of trigonometry here today. It is a very finer degree of measurement than degrees, so it's more precise in shooting. And we can use mils to find the distance of the target, which I'll go over soon, and after we do all this explanation of where mils came from. And so basically we could do adjusting shots for winds and movement of the target, and more importantly, finding the distance of a target. So let's get to it. So radians, milliradians. So basically milliradians, there's mils and a radians connected together. So basically milliradians. So radian here is a unit of angular measurement, and 1 radian equals basically the same distance. It's gonna be the same, okay? And even if it's 1, or it could be like 1 1 2 2 3 3 3 4, and you get it. So it is equal 1 radians subtends an arc equal in length to the radius of the circle. So let me draw a really terrible circle here. Here is my terrible circle, and great, we're going to have a little dot, and that's the center of the dot, and this is radius, and this too is the radius. And to get 1 radian, 1 radian equals, so don't even put the 1 there, radian equals radian arc, and this is both in length. So this is radian arc, and to get that radian, basically these two need to add up together. And sorry about my terrible handwriting. And so off to the next one. So now that we know that, we're going to find out how many radians are in a circle. So we all know the circumference formula of a circle. So circumference, let's see if I could even spell it correctly. Circumference of a circle is going to be 2 pi r, and pi is a constant number, and in this case we have a calculator, so it won't be a problem. And basically when a radius has to equal the radian arc, we're just going to take this 2 pi r and divide it by r, okay? And once we do that, these guys here are going to disappear, and we're going to get 2 pi. And 2 pi, and we're just equals 2 times 3.14159, which equals 6.2832. So that means that there's going to be 6.2832 radians in a circle. That is very key. That goes around the circumference of the circle. I hope you guys see why I did that, the crossing right there. It's because, you know, radius length has to be radian arc, so you're just gonna take it out. And so basically, no matter how long the radius of a circle, you're always gonna have 6.2832 radians that goes around the circumference of the circle. So now we're gonna be saying how many degrees are in one of these radians. So that's another simple calculation that we could do. We're just going to do 360 degrees, and we're going to divide that by how many radians we have, and we know that 6.2832, and that's going to be 57.3 degrees per radian. So you're going to always have 57.3 degrees in each radian, and so that degree is created by having the radius equal to the arc length. And so now we're going to go into mils, or milliradian, and this is where it all ties up to. And this is where I know I've always kind of understood up to this point, then I just got lost. So then milliradians, you know, as you guys know, milli or mil is defined as 1/1000th of something. So 1/1000th of radian. We're going to take each of the radians that go around the circle and chop it up into 1,000 pieces. Since there's 6.2832 radians in a circle, and each radian is chopped up into 1,000 pieces, there are going to be, we'll multiply it by 1,000, and it's a very easy number, 6,283.2 milliradians in a circle. And basically that's shortened up to mils. So now, how many degrees are in each of these little guys here? So this is another easy calculation of 360 degrees divided by 6,283.2. Okay, do in a circle. And that's going. It's already calculated. 0.0573 degrees per mil, right there. So in each one of these little 6,283 milliradians, there's going to be 0.0573 degrees. Great. Now, basically, now that we know that, we want to see what's the measurement of 1 mil at 100 yards, right? So that's the big question here. So I'm going to make a crappy circle again. Excuse me. There we go. And yeah, that's pretty crappy. And that's the center. And we're going to do 100 yards. Right? And okay, so before that, 1 yard equals 36 inches. So 100 yards is going to be 3,600 inches. Perfect. And we could do this the trigonometry way. and I like the trigonometry way, so I'm just gonna waste paper. Yeah, I'm just gonna waste paper and go on to this one, where I will draw an exaggerated view of 1 mil. And remember, this is not to scale. And sorry if I do anything wrong. So this here is X, and this is 1 mil. But we're going to use trigonometry here, so we're going to do at 0.0573 degrees, because 1 mil equals that. And we have 3,600 inches, because we want inches as our unit in X. So we're going to use a quick little equation, if everyone knows tangent, right, equals opposite over adjacent. And my pre-calculus teacher always taught me SOHCAHTOA. SOHCAHTOA. And this is basically sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. SOHCAHTOA, SOHCAHTOA. I just did that a couple times and it's drilled in my brain. It's a great little equation, so we're going to do this equation. So tangent, and the degrees is going to be 0.0573 degrees is going to be, I'm going to have a little x here, haha, x over, so basically so opposite is going to be x, and then adjacent to this degree is going to be 3,600 inches. And once we solve that, and tangent of 0.0573, 0.01, and x equals 3.6 inches. So what this means is 1 mil at 100 yards equals 3.6 inches. Great.